Hello, it's Keith here, and this is lesson 2 of the so-called Chibi Fighter Z80 assembly programming tutorials. Now, Chibi Fighter is a little tech demo, if you will, that I wrote. Basically, it's a sort of parody of Street Fighter 2, I suppose. Now, what we're going to look at today is the code that handles the title screen. Now, if we just start the game up here, this is the Amstrad CPC version of the game, and the title screen starts up with a parody Street Fighter logo here. You can see Chibi Fighter 2 Turbo Hyper Futile. And then what we're going to then go on from the title screen is we're going to look at this screen here, the versus screen, and then the round 1 fight introduction before the game starts. Now, there's a variety of techniques being used to draw these screens, and we're going to go through the various sections of the code today, and hopefully you will find that interesting. Now, all the code you will see today is actually multi-platform code. The game does work on the Amstrad CPC, the Sam Coupe, Spectrum Next, and the MSX2. And this GIF here, this animated GIF, is from the MSX version, I think it is. Anyway, let's go over to the code and let's take a look at what is going on. Now, as I say, the code is actually multi-platform, and that has introduced some technicalities, shall we say. On some of the systems, the game will actually be running from ROM. The code you will see here will be in ROM, and so the variables that the game uses will be in RAM in a separate place. And so what you've got here at the start is the AI strategy variables being initialized from T AI strategy, and the T here stands for template. So we're transferring the default definitions for the strategy into the RAM, because, as I say, often the template will be in ROM, and so we can't change that there. So that's initializing it for those systems. And then we're loading something called the song timer here, and this is actually only needed for the CPC. The CPC has 6 interrupts per frame, and the music would play too fast. And so we're actually, we've got this counter that goes from 0 to 6, and then when it gets back to 0, it will actually update the music, and it will skip through all of the other interrupts. So that's what's being done there. Now, the music on this game is actually being done with my Chibi Tracks music software. This is one of the things the game was designed for. It's not really that amazing a game. It's designed as a test for the Chibi Tracks music software and also for the Mintile graphics. Mintile is a multi-platform graphic tile map engine, which can also do simple sprite graphics. On the systems like the MSX and the CPC, it's sort of a software tile map, if you will. And on systems like the Sega Master System, it's a hardware tile map. So it's very platform specific, so it allows us to do these things in whatever way is most appropriate for those systems. Now, you can see here we're starting the music for the title screen here, and then we're running this blackout routine, which is effectively clearing the tile map to 0. Now, on some systems, we are using 16 color graphics, but the tiles were actually only defined in 4 colors. This was to save memory. By using 4 color patterns in ROM, we didn't need so much bank switching. So we're actually setting the remaining 2 bits of our 4 bits definitions for the patterns using these tints. And so the tint for the title screen is this orange-red tint, and that's what we're defining here. We're then going to load the title tile map into memory. Now, the title screen will show this Chibi Fighter bitmap here, and this is a tile map, and then it will show the text below Hyper Futile. But the vast majority of this screen is actually black, and so this gives us some advantages for compression now that we know this. Now, I discussed the rather painfully complex super tiles before, but the super tiles required that there be no more than 4 different tiles within a 4x4 block, and that won't apply to the graphic of the Chibi Fighter logo, but vast areas of it are blank. And so I've done an alternative method of compression, and so basically the entire Chibi Fighter logo had to be less than 128 tiles. This was because part of the tile definitions were being used by the font, and the Mintile graphics engine and some of the systems I'm working with had a limitation of 256 tiles patterns in total. So because my graphic is less than 128, this leaves 1 bit free within the byte tile numbers that we could use for our own purposes. And so what I've done is I've defined that whenever the top bit is 1, or the top nibble that you can see here is an 8, the top bit is 1, this is actually a number of tiles to skip before the rest of the data. So this 85 hexadecimal byte here is the equivalent of 50 bytes, 5 blank tiles, and that 84 is 40 bytes, and that 83 is 30 bytes. And so, and you can see here there's one in the middle of the stream here. This is 8 in hexadecimal there is 80 bytes that have been replaced with a single byte. Now, the tile map is going to go across the screen and then move down, and then go across the screen and move down. And so those those blocks with the 8 starting with an 8 there are blank areas within it. But when we get to the end of a line, there's no need to draw any 0 bytes here. We can just skip down and move and carry on. And so when our byte is 255, we're actually skipping the rest of the line. So if the line was entirely blank, we would just start with a 255. And you can see here, we've got 85 there, so we're skipping 5 bytes at the start. Then we've got tiles numbers 1, 2 and 3, and then we're skipping the rest of the line with that 255 there. And so this is just a simple compression routine. We could have used RLE compression, but that would have been a little more complex, I thought. So we're using this very crude RLE, if you will. So DE here is our source tile map here. HL is our destination tile map. Now we've got some offsets here because we're not starting in the very top corner of the tile map, but we're going to write our data, and IXL is our line count. Now what we're going to do is we're going to back up the HL destination. We're going to read in a byte from DE, and we're going to check if that top bit is a 1, and if it's not, then this is a normal tile, but if it's a 1, then it's some kind of compression. If the entire byte is 255, then we've reached the end of our line, so we're skipping and we're just continuing with the next line. But if it's not 255, it must be a number of tiles to skip. So we're effectively clearing the top bit, we're moving that into C, and we're setting the B part of BC to 0, and then we're adding that to the HL destination, effectively skipping the number of tiles defined by the bottom 7 bits of the byte we read in. We're then moving on to our next tile, and we would read in again. Now, any other case is a tile that we want to show to the screen. It's part of the Chibi Fighter logo. Now we're adding 96 plus 22 plus 1. Why that? Well, that is 96 tiles of our font, 22 tiles of our background, plus 1 tile which is unused. Tile 0 is transparent within the min tile graphics routine I'm using. So that is why we've got that weird number there. We're then writing that tile into the destination tile map, and we're moving across to the next line. Now, once we've done an entire line, we're basically going to move down 1 full line. We're effectively adding 32 here to move down 1 line here. This is moving us down to the next line of the tile map. The tile map here is 32 tiles wide. We're then basically repeating and until IXL reaches 0. Now the tile cache is 32 tiles wide. Now last time we were looking at super tiles, and that was 36 tiles wide. This is a technicality of the Mintile graphics engine I'm using. It has a cache of changes to apply to the screen and a tile map that is used as the background for any graphics. So if a sprite is moving around, that would be moved into the tile cache, but then when you need to remove that sprite, you read from the larger tile map. So that's why you're seeing a width of 32 this time, but a width of 36 last time. The tile cache is 32 wide, the tile map is 36 wide. That's why that is its technical method by which the Mintile engine is working. Okay, so that has drawn the Chibi Fighter logo. What we now want to show is the hyperfutile text, and that is what we're doing here. We're using this locate and print string routine, and that effectively sets tiles within the tile map as well. We then update the cache onto the screen, which is this repaint screen function, and then we wait for fire, which is just a joystick routine, which will wait for fire. Not very surprising there. Okay, now once fire's pressed, we're going to start the actual game. So the first thing we're doing here is we're setting the opponent number to 0. Now this is the start of a new game. You can go through the 4 possible opponents in a loop. Now new battle is the start of a new fight. Now this means that we're fighting a new opponent. There were multiple rounds per opponent, and there were multiple rounds per game. So what we're going to do, well, the first thing we're doing here is we're clearing all of the sprite variables. Now we've got these sprites, we're actually clearing all of them here, and these are the definitions for the character objects. So you can see there's 2 sprites here. These are the definitions of the position of the object, the bitmap, the animation, and also the AI of the object as required. So there's a lot more than just the graphics data there. What we're then doing is we're running this reset round routine. Let's take a look at that. And what this basically does is it just clears all of the variables to the original defaults. So we're loading the time left in the round here in binary coded decimal, so 60 seconds or 60 ticks if you will. We're loading the positions of the sprites here. That's the enemy sprite position, that's the player sprite position. And then we've got some generic settings for both. The amount of life the player's got, the Y position on the ground, the animator number, this is the animation scripting routine, the Y offset that's about to occur, and the sprite number. Sprite number 0 is the default character sprite. So that's some initialization that we're running as the game starts there. Now what we're then going to do is we're going to clear the screen again. We're going to be basically showing this versus screen that you just saw there. We're then going to clear the screen here, and we're then going to start setting up the players for that versus screen. So what we're doing here is we're loading A with 0. 0 is character Chibico, the player's character, and we're loading IX and pointing it to the player's sprite object, and we're reading in the player settings with get player settings. Now get player settings is a very complex thing, and basically what this is doing is it's loading in the definitions from a template. So it's loading in all of these various variables here for the particular object. Now if we look at player defs here, you will see that we have a variety of definitions for each of the possible characters. This includes things like a pointer to the player's name as a string. It includes a pointer to the animator's scripts, which are actually the same for all of the players as it stands, the bitmap data, the background super tile map, the info for the sprite, which is effectively the tile maps. The sprites are made up of tile patterns, 8x8 patterns in all cases, the music file when the player is the enemy, and the AI sequence for when the player is the enemy. So all of these are going to be loaded in one block here. Now each of these is 16 bytes, so we're multiplying by 16 and adding that to the IY player definition, and then we're transferring from that definition into the IX sprite object. And so this is going to be used in this case to set up the Chibico character. Now once we've done that on the Sega Master System, we actually need to change the patterns within the VRAM memory. The problem is we don't have enough memory for all of our graphics at the same time, and so what we're basically going to have to do is flush out the title graphics and load in the enemy and player graphics, and so that's what we're doing here. And the graphics are of 4 colors on all systems, even though on the Master System there's 16 colors. And so we're defining bit planes 2 and 3 as a constant, and so this tints the characters. So we're using 4 possible palettes. So the enemy character here is using 1 palette, the player character is using another, and the background is using another one again there. So that's why we've got the bitplane 2 and 3 definitions here, and this is loading in the player's graphics. Now what we're then doing is we're showing the Chibico character's name here, and we are running an animation. We're also offsetting the Y position of Chibico, moving it up the screen so that we have a sort of staggered character positions there. We have to run animate sprite to update the sprite graphics from the scripts that define that player's animation. And then what we're doing is we're effectively updating the fireball object. Each player can shoot a fireball, so this is what we're doing here. We're drawing that scene there. The fireballs need to be initialized as well, and so that's what we're doing there. What we're then doing is we're loading in the opponent number, increasing it by 1, and we're looping around the 4 possible opponents, and we're storing that for the next one. Now this means that the first opponent will be opponent 1, which is the Yorita character, and you can see that character just there. So here we're loading in the enemy patterns on the Sega Master System. We're then showing the enemy's name. We're then updating the enemy's animation, and then we're doing some more stuff. We're loading in the AI for the enemy because the player's human controlled, but the enemy is AI controlled. So we're loading in the AI. We're loading in the music for the enemy. We change the music each time. We're showing the versus message here. We're then running this repaint routine, and this updates the background, and then finally we draw the player sprites onto the screen on top of that, and then we wait a while. This shows the versus screen, and then the final thing we're going to do is we're going to show the actual background, which you can see here, and the round 1 fight message. So what we're going to do is we're going to do that here. So we're changing the tint to the background colors, which is the greens. We're then resetting the round. This resets the round of things like the time remaining and stuff like that. And then what we're doing here is we're re-updating the 2 sprites for the player and the enemy. What we're then going to do is we're going to load in the tilemap. So we're getting ready with the address of the tilemap destination. We're skipping the part of the screen that is used by the life bar. That's why we're adding 36 times 4, because the fixed tilemap, not the tile cache, the fixed tilemap is 36 tiles wide, and there's 4 lines for the life bars. So we're skipping that, and we are loading in from pattern number 96 plus 1, because we have to skip the font patterns. And then what we're doing here is we're going to get ready. We're loading in the enemy settings here. We're then loading in the subsprite, the fireball settings, and then we're loading in the background settings, and then we're processing the super tiles from that background. I discussed the super tiles last time, and that's what in this case draws these buildings here. So that's what's going on there. We're then showing the round message. We need to show a number, so we're loading in the round number and we're showing that as a character. The print char routines and the print string routines actually go to the tile cache here. So all of this is being done with the tile cache code, and that means it all runs through the MinTile graphics engine, which is reducing the amount of conversion work by a great deal. We're then drawing the background and the sprites to the screen. We're then waiting for a short period, and then we're changing the text to the message fight. We're repainting the screen again. We're waiting for a while, and then we are doing the main draw of the screen. This is going to update the screen for the main loop. Now the rest of the code is the loop that is occurring for each tick of the game during the gameplay when the players are fighting, as you can see here in the GIF version here. So we're going to go into the details of that next time. So anyway, this game is free and open source, as basically everything I do is. So you can go to the website and download it, and you can use any bits of it you want if you're in your own code, if you find them beneficial. We're going to cover the MinTile graphics engine that does the graphics that you saw here, and also Chibi Sound Pro and Chibi Tracks and all that stuff that does the music. This is my multi-platform open source music software that works on multiple CPUs and things like that. So if you like what you've seen, you could consider backing me on Patreon. That's how I can justify keep working on these crazy projects that really don't produce enough YouTube videos to justify the amount of time I have to put into them. Anyway, hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.